Okay, so here is a special case in factoring a polynomial, so to solve the equation. Um, and so without further ado, here we go. So first thing I look at is this is in quadratic form. You know, x to the 8th, x to the 4th. You've got n x to the 8th minus 26x to the 4th plus 25 equals 0. So this is in quadratic form. So it's in the form of ax squared plus bx plus c, even though it's x to the 8th. Because we can split that thing up, but we can factor it just like a trinomial. And so we'll start out with our two sets of parentheses. And, you know, minus plus is minus minus. That's your signs. In the front, factors of x to the 8th, there's a whole bunch of them. But we can go ahead and split those up evenly. So x to the 4th times x to the 4th is x to the 8th. So in the front, you'd have x to the 4th and x to the 4th. In the back, we're going to put this 25. So in the back here, 25 breaks into either 5 and 5 or 25 and 1. And you know, the product of your roots is 5 and 5 and 25 and 1. The sum of the roots has to be negative 26. So the factor we're going to use is the 25 and 1. And so 25 we'll put here, 1 we'll put here. And if you check those, you know, if you I hate to use FOIL, but double distribution. So if you distribute the x to the 4th through, you know, you'd have just to check to make sure we factored it right, x to the 8th, because x to the 4th times x to the 4th is x to the 8th, minus x to the 4th, minus 25 x to the 4th, plus 25. And if you add these two in the middle, you get negative 26 x to the 4th, which is what we wanted. Okay, so we've factored that. We've got, so I'm going to just rewrite it so it gets it out of the trash there. So x to the 4th minus 25 times x to the 4th minus 1. Here's the thing, both of those are differences of squares. So we can factor this thing further. So x to the 4th minus 25 factors to x squared minus 5 and x squared plus 5. And again, you could distribute that, and it would show you that that does indeed equal x to the 4th minus 25. And then x to the 4th minus 1, also difference of squares, which is x squared minus 1, x squared plus 1. So you can split the x to the 4th up, and then we have that. And so here I have that recopied, x squared minus 5, x squared plus 5, x squared minus 1, x squared plus 1. And we could keep factoring this thing. But now we know that any one of these linear factors is equal to 0. So now you can start setting them equal to 0 and solving for each one of these separately. So x squared minus 5 equals 0, x squared plus 5 equals 0, x squared minus 1 equals 0, and x squared plus 1 equals 0. And so if you solve for these, you know, here you'd add 5 to both sides. And so x squared equals 5. And then you would root both sides of the equation. So in this case, x is equal to plus or minus the square root of 5. That one's good. This one you would also do the same, and you'd subtract 5 from both sides. And so here 5 minus 5 is 0. X squared equals negative 5. You root both of these. And so in this case, x equals plus or minus. Now it's the square root of a negative, so it'd be I root 5. So you've got a couple of imaginary roots in that case. So now we're up to 4 different roots. We've got plus or minus root 5, plus or minus I root 5. Then we'll just keep going with the rest of these. So you add 1 to both sides. X squared equals 1. So x equals plus or minus 1. If you root both of those, excuse me, forgot to do that. So we've got two more roots, a positive one and a negative one. And then the last one, you subtract 1, x squared equals negative 1. You root both sides, and x equals plus or minus, and its square root of a negative 1 is an I. So another set of complex numbers for roots. So if you look at that, we've got 2, 4, 6, 8 roots. And if you go back to the original problem here, or what we started with, you notice that that original problem is x to the 8th, which by fundamental theorem of algebra tells us we're going to have 8 roots. So we've now found them all. And here they are, all solved out for us. And you could have factored here too. You just have to understand what, how that'd be a difference of squares again, but it would be irrational with plus or minus the square root of 5. So, but at this point, I think most people know how to solve a square root equation or with roots, and so hopefully that works for you. And then, not that you have to graph it. In fact, I would encourage you not to, but no, I wouldn't encourage you not to. Yeah, you should factor that. You should graph these. They're kind of neat. Unscripted, late at night. Who knows what I'm going to say? But here's the graph of it. Just if you're curious, I think it's kind of interesting. You've got I just set it equal to y instead of 0. It's x to the 8th minus 26x to the 4th plus 25. Same thing, and you can see the roots in the x-intercepts. Here's negative square root of 5. Just they've approximated it with a decimal. Here's your negative 1. Here's your positive 1. Here's your positive square root of 5. So there's half your roots. It just doesn't have your imaginaries, which would be, located in the imaginary plane. If we could superimpose that. So that's what the graph looks like. Kind of interesting. To me, I like the graphs. You don't have to graph these. I'm more interested that you can find all these roots and factor this for the most part. So hope this helps. Kind of an interesting problem, so I thought I'd make a video late at night here. Best of luck. See you next time.